This Fleet Equipment Unscripted interview is presented by Hendrickson, a leading manufacturer of heavy-duty suspension systems and components to the global commercial transportation industry. Visit hendrickson-intl.com to learn more.
Hi, everyone. I'm Jason Morgan, editor of Fleet Equipment, and welcome to Fleet Equipment Unscripted. Today, we're talking with Yoav Banin, Chief Product Officer with Nauto. Yoav, thanks so much for taking the time to join me.
My pleasure, Jason. Great to be here.
So we're going to talk about some of my favorite topics: artificial intelligence in data-driven technology and truck solutions. Really excited to dive in here. But first, I want to back up for a moment, set the stage for our audience here, because Nauto is a new name to me, at least. I haven't heard too much of you. So if you could do me a favor and just kind of give us a little background on your company, what products you offer, and what segments are you playing in the trucking market right now?
Sure. So Nauto is a Silicon Valley startup company, started in 2016 with the mission of making transportation safer and more efficient. And really what that means is we're all about trying to save lives on the road and save money for fleets. And we do that in a few different ways. Our core business right now is to provide predictive safety solutions for commercial fleets. And what that means is, across any kind of vertical you can imagine, long haul trucking, package delivery, services, utilities, any business that relies on a fleet to deliver its goods and services, then we have a solution for that company. And the way we do it, when we say predictive safety and risk reduction, what that means is AI-based, AI native, originally built from the ground up to be AI-centric, camera-based safety solutions. So what it means is you have a camera in the vehicle that is, on the one hand, looking outside, out of the vehicle, and also looking into the cabin. And it's the AI plus the computer vision. So being able to automatically interpret what is happening. So whether it's risks outside the vehicles, vehicles in front of you, pedestrians, bicyclists, different sources of risk around you, coupled with driver behavior in the cabin. So, are you distracted? Do you have your seatbelt? Are you on the phone? Are you drowsy? All these things that can increase your risk of having a collision and trying to mitigate those. And by combining all of those different sensory inputs, the external risk, the internal risk, vehicle dynamics, GPS coordinates, operating both day and night, we're able to do a few things. The first is we help drivers avoid collisions, predicting imminent collisions. Not only based on, you're about to hit the car in front of you because you're closing in at this speed and so forth, but also taking into consideration the driver's state. So you're distracted, you're looking down at your phone. Let me give you some extra warning time. So you have time to, disengage from the distraction, re-engage with the driving task, and actually avoid the collision before it happens. So that's that fusion of inputs that is, especially unique to what we do. So the first thing is about collision avoidance, helping drivers avoid collisions. The next offshoot of that is because we have artificial intelligence interpreting things in real time in the vehicle, we're alerting drivers to when they are engaging in risky behaviors, as I described, distraction, drowsiness, what have you, sounding those alerts and obtaining an automatic driver performance improvement. So without manual coaching, without human intervention, it's just happening in the moment in real time. I mean, that's the best way we learn things, right? When you're told in the moment, correct this behavior. And that's something where we see typically within a couple weeks of deployment, we see north of 80% reduction in severe distractions and risky driver behaviors just off the bat.
Right. What do you see as the most successful way to implement these solutions within a fleet? Who's most successful? I mean, you've I'm sure heard of the driver pool, and drivers are a talented professional bunch, but also maybe not the quickest adopters of new technology. They like a face-to-face interaction a lot of times. The last year or year and a half notwithstanding.
Sure.
So what do you see working with customers? Who are the most successful in implementing these technology, training, driver feedback systems? What are they doing to make them successful?
Well, I think, and one, of course, is, upfront, you have to be very clear and communicate, set expectations, right? So
Right.
the successful programs are the ones that are, informing drivers, making them part of the journey. We're going to be putting in this camera system. It's not about, snooping on you. We take a lot of care and attention. We really put a priority around the driver privacy and the driver experience. And what does that mean? It means that, for example, we don't have any of these like surprise, supervisor drop-ins. We don't have that functionality. Some systems do that. That's kind of creepy. When you're on your break, you're parked, you're resting, you're having a meal, cameras off. So very respectful about those boundaries when you're not on the clock. First of all, second of all, when you are driving, anything, a very small proportion of that drive time actually gets uploaded to the cloud. It's less than 1%. And it's only when something severe is happening, a collision, a near collision, a severe distraction. And any time that stuff is getting uploaded, the driver is informed. It's not like you're driving, you thought you did fine, and all of a sudden your manager is waiting for you at the depot. Hey, how come you had these 3 severe distraction events? Like, what are you talking about? No, you'll get that alert in the cabin, so you know. And then if it's a severe thing and your manager feels like you have to talk it over, you will have been informed about it already. And maybe you've already self-corrected. So that privacy aspect is very important. We've worked with unions. They've come to accept the system. And we've seen in, some of the videos, for example, drivers nodding off. He's drowsy. You see the tape. The guy's kind of like this. And you hear the, beep, 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 wake up, look at the camera and acknowledge. They nod, they smile. So it's a way like, hey, you helped me out, right? You're my sort of co-pilot here. Or take the case of an exoneration, right? You're being blamed for something, and then now you have the video to show, no, hey, it wasn't my fault, and you're off the hook. That's a huge value and a huge savings for the fleet. So having that communication is paramount. Baselining and measuring is important. So typically when we're piloting a system, we'll run for several weeks just with the camera, with the alerts off. We're just measuring a baseline. Flip on the alerts, and within 2 weeks, you just see amazing improvement. And then you layer on top of that the targeted coaching. And that's where you get enduring improvement over time, because it's easy you get a little improvement, then everything slips back. But if you put in, the whole program, you really see enduring improvements over time. And we've seen fleets who have driven like severe distractions to 0 many months in a row. It's very impressive.
So really quickly, when you say severe distraction, can you give me an example of what a severe distraction is?
So another thing that I think distinguishes our technology and the quality of our AI is not just, yes or no, but our alerts and our events are measured at 3 severity levels. And the severity level, it depends on the type of the alert. But in the case of distraction, it's referring to the duration of that distraction. Okay. So if it's, many seconds, that'll be a severe one, right? Because, we've seen, you'll have systems maybe that are picking up a distraction only after, who knows, 5, 8, 10 seconds. You've driven several football fields by then. Yeah. Our AI, we're very proud of this, is able to thread the needle between sounding, early, because your inclination will just alert on everything, right? Yeah. But then you generate a lot of false positives. You piss off the driver, they don't pay attention anymore, alert fatigue. Worst case, maybe they tamper or disconnect the camera, so you haven't accomplished anything. But because our AI is so accurate, we feel comfortable triggering those early alerts and our false positive rates are super low. So we're able to strike that balance. And then if a behavior continues, then we kind of ramp up the severity of the alert, the repetition, the volume, to kind of, drive that behavioral change.
Right. So, speaking of the artificial intelligence, getting into it, because this is kind of where I nerd out over this kind of stuff, but I find it interesting. And I also find that if we can kind of explain it in layman's terms, that it demystifies a lot of it, right? It's not like this omniscient, all-knowing driver safety narrator that's training. So can you kind of walk me through in basic terms of the artificial intelligence? How do you first of all, where do you get all the data to be able to train the model to say, yes, that's severe, yes, alert on this, no, don't alert on that? And then that feedback loop, right? How are you training it and getting it through, as you say, to kind of thread that needle as to what's appropriate and what's not? And how often is that happening? And do fleets have feedback there?
Right. Okay. No, it's a great question. So we, as I mentioned at the top, we're kind of focused in two segments right now, right? Aftermarket fleets
Right.
and built-in OEM. And having that combination actually generates, to your question, like a data flywheel, right? So we have, we create an algorithm. We have, hundreds of fleets on the road accumulating miles. We have over 1.2 billion AI process driving miles that we're adding to, continuously to improve our models. And so we, the key to our AI, and the reason we've been able to, ramp up the quality of our models so quickly is using an active learning approach. And so what that means is, people are driving all the time. A big chunk of that time is pretty uneventful, right? You're driving a truck on a freeway,
Right.
no big deal, nothing's happening. Imagine if you're trying to pull in all of that data and run it through the cloud and process and train. It would be, days and weeks and months and numerous compute resources. It would be incredibly expensive and time consuming.
Right.
With our active learning approach, we have some intelligence built into the data selection that knows how to pick out the interesting examples. And we train our models not exclusively on that, but largely on that. And so what that does is when we get our sort of model precision, accuracy recall results, it's actually trained on a more challenging subset. So what we actually release ends up, performing even better than what we tested for. But what is important there is, aside from improving model quality, is really capturing more and more of those edge cases, right? And what is holding autonomous vehicles back, right? We've all seen the movies, AVs, they look awesome, they work. It's, we all thought it's right around the corner, but it's not. It's quite a bit out because of all of those challenging edge cases. Think about, for example, we recently announced pedestrian collision warning and pedestrian collision warning plus distraction, which we'll be rolling out, within the year. Pedestrian collision is not a very frequent event. And to be able to train properly on that, you need to have a vast, data collecting network to get those examples of interest.
Right.
So that's where those 1.2 billion miles that I mentioned before and having all those wheels on the road really makes the difference. And you might say, well, okay, well, what are you worried about pedestrian collision, right? It doesn't happen that often. We have fleets saying, oh, we have backing incidents all the time. It's true. Backing happens a lot. But how expensive or catastrophic is it? Usually not so much. Fender bender, a little scrape, whatever. It just happens a lot, so it's a pain in the butt. But you have one, pedestrian situation,
Yeah.
that puts you out of business, especially
Right.
with the way nuclear verdicts are going.
Right.
So our approach and mission is, we know what are the big risk factors, right? What is more or less likely to cause a collision? What is more or less prevalent? And looking at the sort of convolution of those factors, picking off those risky behaviors that we want to attack with our AI, so that then we are methodically lowering a fleet's risk profile over time as we add more and more AI detection capability.
Okay, right. And I mean, you have And given your kind of feedback loop that's happening pretty much in real time with the driver too, if you have an alert, you know if the driver reacts to it, right? The system and artificial intelligence can learn, kind of on that big data scale, how effective these alerts are, how often they correct versus how often they don't self-correct after that. Did they have to warn them 3 times? Did they just warn them once? And building in that's super interesting.
That's all things we can see, but you're right. You asked exactly the right question. What is the accuracy? What is the effectiveness? Is behavior changing? Are drivers reacting? And we build some of that capability also into our fleet application in the cloud,
Right.
to measure, real-time alert effectiveness, coaching effectiveness, because I think historically there's been a little bit of maybe an overemphasis on like the process, right? Coaching. How many drivers did you coach? How many sessions did you do? Did you check all the boxes? So you'll have great coaches who follow that and do well, and others who maybe are less good and they'll just check everything off and nothing changes. So being able to focus on results and outcome versus processes, I think is key to seeing that ROI at the end.
Right. No, and you highlight a really interesting point here too, as we talk about more of these solutions. I guess there are different levels of intelligence, even artificial intelligence, right? I mean, even here, clearly you are far smarter than I am, which is why I call and talk to you so that I know what's going on and the rest of the industry knows what's going on. But how do you build, like, clearly every fleet doesn't want to have to go through all the video for themselves and double check
Sure.
what was accurate and what wasn't accurate. What do you recommend the fleets that are maybe trying these solutions or looking at this? They want to go down this road, but how do you build trust in artificial intelligence?
Well, I think so. To your point, one way is what we just talked about. There's sort of that manual validation. But the more, I guess, automatic way is, as I mentioned, the key events, the severe events are getting uploaded to the cloud. So, a fleet manager, a risk manager, or someone who's evaluating the system, um, can sample on a sampling basis, look at some of these videos, see that it makes sense. Every now and then there's a miss, and there is a mechanism within the application to say, I don't agree with this assessment. I wasn't tailgated. And then it'll go back to our review process and, we'll take another look and maybe we'll fix it or change it. So there is that feedback loop. But I think it's enough that if you look at a few of these videos, you'll start to be convinced that, yeah, this stuff works. It's accurate.
One quick question here for you, because you mentioned identifying the driver risk, identifying the indicators of risk. How are you doing this? Is that happening in the cloud, right? So the video goes into the cloud and it's processed there, or are you doing that on the device in the cab with the truck and the driver?
So that's a great question, Jason, because oftentimes where and when that stuff is happening is not clear. So first of all, we do a big chunk of that processing and analysis on the device. That is very important because that is what allows you to alert in real time and actually do that collision avoidance and prevention. Systems that are going to be only cloud-based, that's going to be after the fact. The latency is too big. You cannot impact a situation that is evolving in milliseconds. So that is a really big differentiator about what we do. Real time in the cab. We have, powerful compute in the camera, sophisticated optimized AI that makes it possible. That is super important versus having a real-time prevention system versus a post-facto, crash and coaching recorder. At the same time, we have additional processing that happens in the cloud, to sift and filter different events and so forth. And that helps, after the fact coaching that I mentioned, to really focus on the key results, to generate driver scores so you can really know where the risk lies. So it's really the two. But again, I want to really underline the real time in the cab component.
Right now, and that's important too, because we are talking a lot about the 3G sunset, right? There's still a lot of trucks out there with even just not even video-based telematics, but just regular telematics systems that need to be upgraded. But even then, even the speeds at 4G, LTE, and up to 5G, I don't think we're there yet in terms of how quickly you're talking about alerting the driver. That definitely has to be an on-device thing to happen.
If you want to help avoid collisions, it has to be on the device, and you have to be most effective, to combine all those inputs that I mentioned at the top. You know, the in-camera, external camera, IMU, the vehicle dynamics. It all needs to be happening in real time if you're going to make a difference. Otherwise, again, you're relegated to being after the fact. Sometimes that's going to be too late. You know, collision happened, or it might be too late if, you know, you're getting an event in the cloud 2-3 days later. Which driver is going to remember that and use that as a basis to improve their performance?
Right. Yeah, for sure. Very cool. Yoav, I appreciate you taking the time. I've learned a ton. I'm sure I will talk to you again very soon.
Anytime, Jason. It's been a pleasure. Thank you.